So now we're on.
Wait.
What? Wayne, what are you doing?
Shh, I'm listening.
Wayne, what are you doing? Why are you wearing a monocle?
You are indeed fit to do the Solids of Revolution video. I was just checking, I'm a doctor.
You're a doctor now? Is that
Yeah,
the monocle and the...
Yeah.
Oh, a vet, isn't it?
Well, all good doctors are vets.
Oh, I see. Oh, wait. No, you're not a doctor. No, it's not. That's not how it's on. I'm a doctor. I'll just take you over.
Oh, that would explain the multiple heartbeats. I thought you were pregnant.
No, it seems you are as well, and you might want to have a lens. You don't look well. You look lovely, but
Yeah, now I can see. That's a good idea.
And now you can see. Oh yeah.
Now I can hear, so I can actually hear your good idea.
Right,
That's good, isn't it?
Now you can walk.
No.
Anyway, now on to Solids of Revolution, which sounds a bit terrifying, and it sort of is, but not very. So it's like integration, but in 3D. So if you have like an axis, and it might have a shape, like a cone or something, and it will go around a little circle. So it'll be 3D, and it'll say find out the volume. So you know how to find the area, that's what you do to integrate. That would find the area of this triangle. But to find out the volume, you have to rotate it by 2 pi radians, which is where our formula's coming.
Yeah, turns out I can walk.
Can you?
Yeah. Also,
wow.
I found a nice example.
Well, that's lovely. Where did it book from?
It's just down there. So much more you can see without a monocle.
Oh wow.
Don't wear a monocle, kids.
They're bad.
They're lovely though.
They look cool, but you know, your glasses, I don't know why you'd only want to help one eye.
It's just discrimination, really, isn't it?
It is. Yeah.
So I've got a nice worked example.
Alright.
You ready?
I'm ready.
Write up some stuff.
Okay.
So, the region under the curve y equals...
Alright.
So, 1 plus x on the numerator,
Okay.
x on the denominator, and all of that is square rooted. Between the points x equals 1
Okay.
and x equals 4
So it's going to be like a thing like that.
is rotated through 2 pi radians about the x-axis
Okay.
to form a solid of revolution. Find the volume of the solid. Typical question to be asked. The hard part is the integration, really, but we'll go through the new formula.
Yeah, well, the first thing to notice is as it's rotated through the x-axis, you're going to use in the y formula because it's up and down.
Yeah, so it's going to look like this,
Yeah.
rotated around the x. And as Joe said, y is what you're looking at, so we've got a neat little formula.
Okay.
To find out, well, what you've got to do is you've got to integrate pi times y squared.
And that's why they're giving you this as a root, because then you just get rid of the root.
Yep. So you can input your y in here, but first I'm going to take the pi out.
That's a good first step.
Pi, and then integrate y squared as Drew said.
Yeah, which is just 1 plus x over x. And that's not very nice, this is where you use your integration rules, but I've just split this up. So you have 1 over x, and then x over x, which is just 1.
Yep. So
Remember this is between 2 points, between 4 and 1.
So if you integrate that, you should know from integration rules that integrating 1 over x is ln mod x.
It is.
So you've got ln mod of x.
And if you integrate 1, you just get x.
Yep. Condoning a plus c in the exam papers, but now we're going to go ahead and put in our 4 and 1, so we don't need the c.
So now we're going to put in our 4 in place of the x, and a 1 takes the x, and minus 1 from the other.
Ln mod 4 plus 4.
Take away ln 1
plus
1. So this
All of
bit,
this times by pi, just mention.
and you could all do this in your calculator, but often they like it in a bit neater form than decimal numbers. So it's good to sort of see if there's anything you can notice that will be not in your calculator.
Yeah, and I have noticed one thing.
You've noticed one thing, have you?
Yep, I have noticed one thing.
What thing have you noticed, Wayne?
That painting on the wall.
Oh, that's a lovely painting. I
never saw
tinsel's
that.
a good touch, isn't
Yeah,
it?
it's lovely to be Christmas.
You know, I've noticed something as well.
Have you? What's
Yeah,
that?
yeah. 1 and 1 is 0, Wayne.
And I'll tell you why.
Okay.
If you draw the Lund graph.
Yeah, the long graph. It's
That was quite a terrible drawing, but it looks like that.
It
and
does.
goes through.
so when y0 is 1, so ln 1 is 0, which is handy. So it just becomes ln 4 plus 4, which is ln 4 plus 4, minus 1.
And I can do 4 minus 1.
Can you?
Yeah.
Oh, wow.
It's not 2.
It's not 2.
It's not 5.
It's not 5. Is it?
I'm going to write the answer up here.
Okay.
So it's going to be ln mod 4.
Absolutely.
Plus
Plus 3, because that's 4 minus 1.
And we can take away the square brackets because we're now not doing a thing and just
And
put a pi
pi outside of it. And it's actually neatest to leave it like that.
Yeah, if you extend it out you can get a decimal and that would be more inaccurate than displaying it like
Yeah.
this simply.
So this is lovely, and that's in the x-axis. The only other way they can ask you is in the y-axis.
You know
Why
what, I
would
think
they do
we
that?
could find an example of that as well.
I reckon you could.
Yeah.
Alright, so I'll rub this off and then you can...
Okay.
Oh. Wayne? Oh, he's dead.
So I've got a worked example. Driv?
Oh, Wayne, I thought you'd died. I made a funeral arrangement, so I got the cars, I got a monocle up. I nicked your monocle, it's gone now. But I thought you wouldn't need it, because if you were dead.
Well, no, I was just getting a worked example up.
What?
That's how I found it before.
What?
Where did you... I was just getting a worked example up. That's how I did it before, as I fell on the floor, you see.
Oh, right.
Question though, where'd you get the cars from?
Oh, I just nicked yours, you're dead.
That's okay, as long as you get them from the right source.
Oh,
I don't
yeah.
want you to scam me out.
No, that was only ketchup.
There you go then.
Alright.
So the curve in this diagram,
okay.
we're going to have another question here, has the equation y equals an 8th x cubed, and it says to find the volume of the solid of revolution formed by rotating the region labelled r through 2 pi radians about the y-axis this time.
Okay, so as it's about the y-axis, we have to use the x equation.
Yep.
But I've noticed something, Wayne.
Have you really?
Yeah, this is y equals. You want x squared equals or x equals a root, right?
We do indeed want that. Yes.
Oh, and this is
I'm
this
just
is
drawing it briefly.
that's a diagram that's in the book. They haven't told you the points it's rotated about, but seeing these 2 points here is between those two.
And yes, you had a good point there before I was drawing the thingy.
Okay.
This is y equals, and you do have to get it an x equals, but not only x squared.
So let's do a bit of rearranging.
So firstly, I would like to get rid of this 8th.
I would as well. So as size by 8, you have
8y equals x cubed. To make that squared, you're going to have to cube root both sides.
Yeah, and then we have to go back up the square. So we can cube both sides, cube root the 8 as well.
Yep, so that's 2, and then y to the 3rd equals x.
Then you square both sides.
You do. So that's 4, y to the 2/3, remembering your powers rules, equals x squared. Before we had y equals root, and we just went straight into putting it.
Mhm.
The reason being, root is easy to square. You could have wrote before y squared equals and got rid of the root, and then put it in. But before we just did it in one step because it's easy to square. As long as what you're putting in is x squared.
Then that's fine.
So now we can go ahead and do that.
We can?
I'm going to get the red pen because this is bound to be evil.
Yes. The x ones are often more evil. They could choose either be evil. They can do the same thing to each because they're essentially the same from different sides. But this one is the evil one, often.
So we know what x squared is now. It's
We do.
y.
The 2/3, and we're going to integrate this.
So, first step first, I'm going to take out the pi.
Yep. It's always a good step because you often can't do nice things with pi. It's like good to take out all irrationals nearly always because nice numbers don't arrive from irrational numbers.
I could have taken out a factor of 4 pi, that would also have worked.
Yeah. I don't like taking 4 out though.
No, we can just keep it in.
Yeah.
It's just
You can integrate
numbers.
4y to do that, it's fine.
You can take out 4y and it would give you the same answer in the end.
It would.
So I'm going to go ahead and integrate this.
That's a good plan. So in order to integrate, we increase power by 1 and divide by the new power. So we're dividing 4 by 5/3.
Yep.
So that's
So 4 over
5 over
5/3
3. Yeah.
is the same as 12 over 5.
It is the same as 12 over 5. So you flip it and then times them.
12 over 5, not 5.
Y to the 5/3.
y to the 5/3 plus the to come down. So we've got to
Yeah.
do the thing where we do 2 brackets and times it all by pi.
Absolutely.
However, we're not quite ready.
We're not quite ready because we have 2 points, but they're x values.
They are, and we're not integrating with respect to x, we're doing it with respect to y.
So we need to turn these into y values. But wait, how are you going to do that?
Well, I'm seeing this equation
Yeah.
of what y equals.
I reckon that might come in handy.
Yeah, because we want to find out what y equals.
Oh wow, so let's put those in. So we have 2, so 2 cubed is 8, and 8th of 8 is 1. I can do that.
So y equals 1 when x equals 2.
Yeah.
Just to be clear to the examiner.
And x equals, when x equals 0, so does y. That's handy.
So what we're actually going to be putting in here isn't the 0 and 2 points they gave us,
It's just 1.
but the 1 and 0 points that we're going to be doing. And when you put 0 in there, it's just going to be 0.
So we're going to ignore that. So then we have 12/5, lots of 1 to the 5/3.
Which is
1
just,
to any power is 1, so it just becomes 12/5 of pi,
and that's times by pi.
which is important not to forget.
And
And then we have our answer. You can see this is quite a bit more awkward, and this is why this is a later chapter in the book.
The only thing they can really do to make it harder than this is horrible integration things.
Yeah, they give you some of the things from the past chapter. They can make them really, really, really nasty.
So make sure you brush up on your integration to be clear on your solids of revolution. Make sure you brush up on your differentiation to be clear on your integration. Make sure you brush up on your y equals e to the x and ln x to be clear on your differentiation.
And make sure you brush up on your paintings and clean your brushes, because brushing up is important.
Very important.
Very important. We're not going to do a taste exam question because it'd just be another one of these.
Plus, there's none in the book that are from the past exam papers, but don't think that means it doesn't come up. They do come up, but they're always tied in with integration
Yeah,
questions.
so it's
that's
actually
part.
meaner than this. But you can go. You got this.
We'll see you at whatever the next
Numerical methods.
chapter is, yeah?
Yeah.
Numerical methods.